Alright, so in this discussion I'm going to go over seasonal load, base load, and home heating index, which can be used to evaluate the basic efficiency of a building, a residential building, before you even visit it. Okay, so base load and seasonal load. These are important concepts in energy management and the energy use in a building. So base load is it's the portion of your energy that pretty much doesn't change from month to month. So there are certain things that you do year-round, like use lights, television, refrigerator, charging electronics, so forth. So that's considered part of your base load. So in this chart here, this is a chart of we have kilowatt hours here on the y-axis, okay, and then we have the month. This is April, May through March, okay, and you can see the gold part of this chart is my base load. Okay, so you can see it changes a little bit, but it generally is pretty flat year-round. So it doesn't matter if it's the middle of the winter, that portion of my energy use doesn't really change. Middle of the summer, it's still about the same. Middle of the fall, about the same. Okay, so that's my base load. Whereas the seasonal energy use is heating and cooling loads, basically. So that changes a lot. So in this chart, the I don't know what, maroonish, reddish portion of the chart at the top, that's my seasonal load. Okay, so it peaks in the summer when I have extra cooling energy. It peaks in the winter when I have extra heating energy, and then there could be a little bit of seasonal in these shorter months where I need some heating or cooling on those months. Okay, so that's your basic base load seasonal load. In order to calculate the base load, it's actually pretty easy if you have a year's worth of utility bills. So you take a year's worth of utility bills and you average the 3 lowest months of use. That's it. So you're going to do this in your lab. You're actually going to look at some real utility bills and calculate the seasonal and the base load. And then, so for your base load, you take the 3 lowest months, you average them, and you assume that that's your base load that you use every single month. Okay, so let's go over an example here. So this is a year's worth of utility bills, rather a year's worth of energy use from utility bills. Okay, so we have kilowatt hours here, CCFs, or natural gas, in the bottom row, and we have January through December. So feel free to go ahead and pick out the 3 lowest months of each energy use and average them out and see what you get for base load. Okay, so go ahead and press pause and do that. If we do that, okay, for kilowatt hours, our 3 lowest months are 500, 450, and 500. Add them up, divide by 3. So my monthly base load is about 483 kilowatt hours. You multiply times 12 months in a year, 5,800 kilowatt hours per year is my annual base load for electricity. For gas, 3 lowest months, and it doesn't matter. You can see we have 25, 25, and 30. It doesn't matter if you take this 30 here or that 30 there. It's still the 3 lowest months are 25, 25, and 30. So you take those 3, average them out, you get 27. So I get 27 CCFs per month is my average base load, times 12 is 320 CCFs per year is my annual base load. And it's really that simple. Okay, so if you want to calculate the base load, you take the 3 lowest months, you average it out, and you just assume that you're going to use that much every month of the year, regardless of what time of year it is. Okay, so I want you to think about which of these energy uses. So this is the breakdown of a typical all-electric house in Pennsylvania. In the major energy uses of the major electricity users in that house. So you can see it's mostly space heating, water heating, some cooling, some lighting, refrigeration, clothes dryer, and other. So feel free to press pause and think about which of these would be base loads and which of these would be seasonal loads. And we're going to go start with space heating and work our way around. So space heating, by definition, is my seasonal load, right? Because it changes depending on the time of year, and it's going to peak in the cooling or the heating season in the cold part of the year. Water heating, now be careful here. This is base load, okay? Because we use hot water year round, showers, cooking, whatever. So that's something that again, it's going to change a little bit from month to month, but it's generally going to stay about the same. Cooling is seasonal load, obviously. Lighting, we use that year round, so that's base load. Again, that can change a little bit, but it's generally going to stay the same. Refrigeration, Think about it. We use a refrigerator year-round. That's base load. Clothes dryer, a little bit tricky. This really depends. For most people, this is a base load because you run your clothes dryer year-round. But some people do dry their clothes at certain times of year on like a clothesline, in which case the clothes dryer would become a seasonal load. And the other stuff is like your electronics, your your TV, charging your cell phone, computers, that sort of thing, microwave, whatever. That's base load. We use that pretty much year-round. Okay, so that's the difference between base load and seasonal load. Just as a reminder, heating degree days tell you basically if the amount of it gives you a sense of how much heat you need to provide to a building in order to get it to a comfortable indoor air temperature. And remember, higher heating degree days means it's generally colder, right? So the high, like 10,000 plus heating degree days are up here in northern Minnesota, northern North Dakota. And then our low heating degrees like 1,000 or less are down here in the southern parts of the U.S., right? So basically, more heating degree days means need more heating, which means it's colder in general. And the reason I'm bringing this up because we use HDD to calculate a home heating index, which you're going to do in your lab as well. So home heating index gives you this sort of general benchmark of how efficiently your home is being heated. It gives you a feel for how efficient a building is. Okay, just gives you a feel. And the scale is here on the right. This is also in your lab as well. But it's pretty easy to calculate. Now getting the numbers isn't necessarily simple. But once you get the numbers, they're pretty straightforward. So all you do is you determine the total heating load in BTUs. So not just the load and not the seasonal load, but the total heating load. And you divide that by the square footage and the heating degree days. And that's it. Okay. So BTU of heating divided by square foot times HDD. So I want you to think about why would we divide by square foot and HDD? All right. So think about this real simple equation. BTUs go up, your home heating index goes up. That means you go up higher here on this scale, which means you're requiring more heating, which is an indication that your house might be less efficient. Okay. Whereas if your square footage goes up, your HDD goes down. If your HDD goes up, if your square footage goes up, your home heating index goes down. If your HDD goes up, your home heating index goes down, right? So they're inversely related, inversely proportional. If you think about it, if I have a certain number of BTUs of heat, right? So this is BTUs of heating. And I have a really big square footage, okay? So I have like a 1,000 square foot house and a 2,000 square foot house. If they both require the same amount of heating and they both are in the same climate, you figure, well, it's a really big house and it only requires as much heating as a house half its size. So that means it's probably a little bit more efficient than that smaller house, right? So if I have this giant house that only needs the same amount of house as your little house in the same climate, then that's a really good indication that my giant house is actually pretty efficient relative to yours. So that's why you divide by square footage, because it sort of normalizes that. You would expect a house twice as big to use about twice as much heating, all else being equal. Okay. Now HDD, you divide by that same principle. If we have two of the exact same houses that use the same amount of heat, but yours is in whatever Maine, up in where it's really cold, and mine's down in North Carolina where it's not that cold, and we use the same amount of heat, and yet you live in this really cold climate, that means your house is probably more efficient, right? So in Maine, your HDD is a lot higher than it is in South Carolina or North Carolina. And so if you're using the same amount of heating, that means your home is probably a little more efficient, right? So again, as the heating degree days go up, if your HHI is pretty low, or that's going to drop your HHI if you're not using a lot of heat. Because that's an indication. If you have like this big house in a cold climate and yet you're not using that much heat, that means you're probably have a pretty efficient building. Okay, so that's kind of how that works, right? So let's do a quick example of this, or partial example anyway. So if I have a 1,500 square foot house with a 4,500 HDD of 4,500, okay, and I look at my I need to find my heating load in BTU. So I have my square footage and I have my HDD. So in order to find my heating load, what I need to do is figure out, okay, what is my base load first. Okay, so I need to figure out my base load. My electric base load, this is the same example as before. So it's about 483 kilowatt hours a month. My gas base load is 27 CCFs per month. Okay, so if I look at this energy use, I need to think about which energy am I, or how much energy am I using to heat my house? So how much energy am I using to heat my house? And what you want to think about is, remember, the base load is energy that you use no matter what time of year. So that's not used for heating. Okay? So you need to think about which months are heating months. And in those months, you figure, okay, well, I'm going to use, let's use December as an example, because we know December is a cold month up here on the East Coast. So my seasonal heating load in December, okay, you can see my December energy use here on the right. It's 1050 kilowatt hours and 130 CCFs. But remember, some of that is base load, not seasonal load. So I need to subtract out my base load, and that'll tell me my approximate seasonal heating load. So I take 1050 kilowatt hours minus 483 kilowatt hours, which is my base load, okay? And my assumed heating load in electricity in December is 567 kilowatt hours, because that is the amount of electricity above and beyond my base load that I used, okay? And the CCFs, the natural gas, 130 CCFs, I subtract out my base load, right? 27 CCFs per month. And that means my heating load is about 103 CCFs. And so combined, you convert all of that to BTUs, right? Like this should be easy at this point. Basic conversion factor. So that means my heating load in December alone was about 12.5 MMBTU. Okay, 12.5, 12.49 MMBTU. And remember, we did that by first taking the total load of the month, and then you subtract out that base load, because that is not heating, and then the remainder is you would consider your heating load. Okay, so for your lab, what you need to do is think about which months are you're going to use heating. It's not perfect, but think about the time of year, and think about which months you're most likely to use heating, and you'll kind of see what happens. The base load, you sort of use your base load at certain times of year, and then after that, it's going to be in the cold months, it's going to be your heating load. Okay, so that's how you figure out your heating load, and then you need to figure out your heating load for the entire year, okay, which would be all the heating months. And you add all those up, divide that by the square footage, divide that by the HDD, and then you'll have your HHI, your home heating index. So if you work this one out, this was an HHI of about 8.8, if you did all the math. And that tells you that you're kind of a moderately efficient house. So according to the chart, there are opportunities to save energy and money, and should be easy to find. It's an average home with average insulation, average leakage, average efficiency. Okay, so you can do, the cool thing about HHI is you can do this before you visit a house, and it gives you some indication like, wow, this is a really inefficient home, or you know what, this is actually a pretty efficient home. So it gives you some kind of indication of what it's like before you go in it. Okay. All right, so now you want to know what a seasonal load is and a base load is, how you calculate each of them. We reviewed heating degree days and how you calculate the home heating index. So this will help you with your lab this week, as well as the quiz.